Hello everyone, like Jake said, my name is Adam Nodal. I'm one of the application developer 3s here at Buildertrend. I work primarily with the architecture team, but also team lead here and there. Bounced a lot around the development floor. So my presentation is primarily on advanced troubleshooting performance tuning in .NET. I'm going to talk about some of the issues that we've encountered here at BT and like some of the potential solutions that we've had for those issues. Quick overview of our presentation. Just to give you some background, I've been here for about 4 years. Over those 4 years, we've encountered a lot of issues trying to scale up our platform, a lot of issues that are just unknown bugs that took quite a bit of time to debug. These are some of those issues and the solutions for those issues. So currently, you may not have encountered these issues. They're issues that kind of happen upon scaling up platforms or more complicated like performance issues as you scale up requests, everything else. So your mileage may vary. Anyway, so I have code examples for every single, well, almost all of the things here. Those code examples kind of demonstrate why we went with the solution we did and like what the problem was, etc. I'm going to ask that if you have questions during the presentation, just bring them up during the code examples, because then I can kind of explain the code more and give some context as to like why I came up with those different solutions. So, quick overview of the presentation. Going to talk a little bit about serialization, organizing caches, memory usage and CPU usage in the .NET framework, and proper reflection. I'm not going to go too deep in reflection, but I will talk about some common mistakes that I've seen in the .NET platform specifically. So, starting it all off, binary serialization. This is something that we don't encounter as much anymore. We often work with JSON serialization in today's day and age. But whether or not you believe it, there's plenty of situations for you to encounter binary serialization. Cache servers, for example, will often take in byte arrays as their source, and a lot of people by default will fall back to binary serialization, or if you're running a web platform, session state servers will run binary serialization. These things actually this particularly comes with some side effects, and we've discovered those over time. One of those side effects is, so any type, first of all, let's define what can be binary serialized. Any type marked with a serializable attribute can be binary serialized. That essentially allows the type to be defined to a byte array and deserialize it from that byte array back to the original instance of the object. There are some niches about that, but we'll get to that soon. The main thing is it's restricted by assembly version and type. I bring this up because we used to increment our version number on our DLLs. This caused type deserialization failures upon deserializing from cache. So it's something to definitely be aware of. It's very strict on what types can be serialized and deserialized. Another thing we found is constructors don't get called by deserialization. This is something that kind of can just be forgotten about as you're progressing through programming. But if you binary serialize something and deserialize it, when you deserialize it, it won't call the constructor. So that can have some unknown side effects if you're working with objects that depend on the constructor being called. So one way to alleviate that problem, as well as some other problems with serialization, is custom deserialization. That allows us to define a constructor, passing in serialization info and streaming context as the two parameters. It requires implementing iSerializable and also manually serializing and deserializing, so you lose some of the ease of binary serialization in .NET, but it does help with reconstructing those objects as well as serializing them properly to cache. So another thing that we've discovered is dirty tracking on database entities. One of our examples is we encountered a situation that caused all dates deserialized from cache to end up being marked as dirty, obviously causing some pretty massive database failure, like database issues, as well as some bad data. So when you guys are serializing database entities, be aware that dirty tracking can be affected. Like even with Entity Framework, if I serialize an entity at state A, and that state changes by another operation in the future, like during its time in cache, then when I deserialize it, that data may not be valid. So it's something to be aware of when serializing entities. So binary serialization is really not one of those things that we've chosen to keep with. We've decided that most of our entities and everything else will be serialized to JSON from here out. Oh, hey, there we go. So, migrating binary serialization to JSON. Essentially, when we binary serialize something, we lose some of that JSON default serialization. Newtonsoft, in our situation, actually serialized backing fields to try to mimic the serializable attribute. So, as I mentioned, when you mark a type with serializable, you give the ability to binary serialize it. But Newtonsoft, in our version of Newtonsoft, actually changed the way it serialized JSON entirely because of that object. So we discovered that you have to mark classes with both serializable and JSON object if you're trying to migrate from binary serialization to JSON serialization. This is just one of those things that we discovered from the trenches, if you will. So once you mark both the types with serializable and JSON, you can now start to migrate away from binary serialization. Once you're sure that all of the dependency upon the binary arrays that you serialized is gone, that code will never be hit again, you can end up removing that binary serialization attribute, the serializable attribute. So I have some code examples to show how binary serialization functions. Most of you probably have encountered some of this before, but pull this open. Give you guys some context. So essentially, I wrote a couple classes where they're binary serialized and deserialized, and then they're also serialized and deserialized from JSON. So the biggest note is I left a console.write in every one of the constructors to show that upon deserialization, we lost the constructor call, right? So when I first entered into the test, I had, actually let me define these types real quick. So if I go down to my type, the constructor I was using was this constructor with ignored value. This just set up all of the individual fields. This is a very simple object. We have 3 fields, one that's ignored by the non-serialized attribute, one that is just a property, and then an underlying protected field, right? So these things, just a pretty standard object. So upon instantiation of it, I obviously set all of those different fields based on the parameter passed into the constructor, right? Everything's fine and dandy. Well, I marked one of those properties with non-serialized. So what that'll do is it'll prevent it from being binary serialized. So after the serialization, we saw that ignored field ended up empty, right? Obviously that's intentional, but it's something to be aware of, again, during binary serialization. So let's say one of our situations is we would often mark something as non-serialized and then have it handled in a custom deserialization. This is a valid strategy to try to mitigate type changes and things like that upon deserialization. So I created a custom serialization logic into my other type. Obviously made it so that it populates everything now, having whatever logic I chose to populate it. So on the second test, I created it. Before serialization, we see that all those values are there. After serialization, we see that the values are still there because I had that logic in play to deserialize even the non-serialized fields. An example would be if it's a calculated field and it depends on the state of the objects at the time, right? Ignored field in this case was just something that was computed, right? It was just a to upper call or whatever else. If that's the case, then maybe custom deserialization logic would allow me to define that upon deserialization rather than expecting the binary serializer to handle it. What we've personally used this for is dirty tracking. Upon serialization of our entities, we store them as though they were pristine and clean and didn't have any dirty properties. That's probably not ideal, but again, there's no way to know what properties were actually dirty if you serialize a database entity. So upon deserialization, we obviously had logic to properly clear out the dirty logic, right? We reinitialized all the fields, and then we cleared out whether or not they were dirty, right? So we get the same object in, same object out, even with our custom logic. So that's pretty much all I had. I did also have an example where I marked the type with both serializable and JSON object. .NET Core, Newtonsoft apparently doesn't have the problem of backing fields But when we had this issue a while ago, a state server object, we converted into a JSON array because we wanted to often modify what was stored into session. And if we used a binary array, or if we used binary serialization, those fields would never be initialized. We would never have that ability unless we implemented our own. And at that point, it's like, why don't we just use JSON? So we converted a session object to JSON, but it broke both the binary serialization and JSON serialization because it saw that it was marked serializable, and it serialized the backing fields differently. So when it deserialized it from JSON, it was broken. And then we tried switching it to just JSON object, and obviously that broke binary serialization because serializable has to be there for it to be deserialized properly. So this is just something I wanted to bring up to show how to migrate properly from binary serialization to JSON serialization. But any questions about that? All right. So moving on. Obviously with serialization, I was talking a lot about cache. Well, what is cache? First of all, cache is usually some external server that you use to store some data that you access constantly, right? So in our case, we store some of our very, very commonly used entities in there, right? So builders, for example. Well, we ran into a problem. We wanted to have a set number of cache servers, all managed by infrastructure, and to have the development environments to operate the same as test and prod and everything else. Well, how do you get the same cache server to work across all these different environments? Well, we started defining some rules around cache keys specifically. The biggest rule is we had a memcache, well, we called it memcache prefix, but it was a caching prefix that changed based on environment. So the developer environments would base it on machine name, test environments would base it on just a test string. Prod would probably not have a prefix, staging, etc., right? So what this did is allowed us to reuse the same cache server across all these different environments and never have a cache key collision, and we would never have to worry about where the data came from those different caches, right? Because I could connect to different databases in all the different environments and still use the same cache server. So this allowed us to have a more test-like environment for developers. Obviously, from there, we need some other identifier for each unique type of cache. This, again, we had just another prefix. So we have environment prefix. Now we have, what entity it was as a prefix. So, for example, we would cache builders with a prefix of builders, right? So from there, we still need something to identify each individual row in cache, right? If I'm storing a builders entity, I probably have multiple builders. Well, I need to define some unique identifier per builder object. So IDs are a great way to make completely unique keys across the board, right? So combined with all of the other keys, we never have a collision. Every environment has its own cache. Every entity type has its own cache. Every row has its own, row and cache. So, for example, I had a little cache T here. It seems simple, but this really makes it so that our cache servers can be used across environments. We don't have to configure an environment for each individual situation. Developers can share one cache server without it, constantly having collisions or bad data or whatever else. So, very simple. Yeah.
What do you guys cache?
What do we cache? Well, we cache as much as we can, pretty much. The main things we cache are some of the most commonly used database entities. We cache, builders, for example, represents one customer. Whenever that customer logs in, we need to get configuration data, et cetera, from that builder. So since those builder objects are going to be accessed constantly by the application in every single request, to try to retrieve whatever configuration values we have, we store that in the cache. We do the same thing with job sites. Job sites define one working area for a builder, right? So if they create a new house, that's a job site to us. So obviously, when they have that job site selected, we need to get that data all the time. So anything we access constantly, especially stuff we access on every single request, we cache it. One thing to note is if you do cache database entities like we do, you have to have cache busting logic. So that's a little side note of, once you update the entity, you have to make sure to clear out that record from cache, right? Avoiding the stale data issue. Does that answer your question? Nice. So moving back to the .NET world, one of the biggest things that we've encountered is actually memory usage. Memory usage in .NET can be kind of a hard issue to debug. And I've used personally Visual Studio's built-in performance profiler, as well as a tool called NProfiler. And for these CPU usage and memory usage tests, those are all based off my discoveries from that. I would show you guys some of that, but I'm short on time. So at any rate, so delegates. Obviously, we all probably know that delegates basically define a function pointer. So when I define a delegate, I define some address for calling a function, and when I invoke that delegate, it'll enter into that function, right? What's unknown is delegates often cause a pretty massive amount of memory loss depending on the situation they're used in. So delegates created from a method, specifically from a method, have to be recreated every single time they're referenced. This is one of the C# specs. So this is built-in, intentional .NET framework type of logic. Now, that doesn't sound like a big deal, but it's literally every time that method is called, right? So if I have a method, for example, where I declare an action delegate down there, right? Every time I hit that line of code, the memory required for that delegate is recreated every single time. That's part of the C# spec, so it's intentional. Lambdas, on the other hand, are actually cached by the runtime. This is another C# spec. So what does that mean? It means when I hit this code again for the next time, I can actually refer to the original created delegate. And depending on the situation, obviously .NET will eventually dispose of it and recreate it. But for the most part, I'll see less memory usage by using lambdas. So another thing is there's obviously local functions. This is something that's newer in the .NET world, but they pretty much follow the same rules as though they were lambdas and functions combined. So the last thing I wanted to mention here is closures. Hopefully we all know that if we create some kind of method inside of another method, depending on the resources I use inside that other method, I can actually retain that memory for an extended period of time. So closures and local functions, when referenced via a delegate, will never release that local memory until the delegate itself has been released. So it seems like a minor issue, but I have some code examples that will show it might not be. So if I pull open here, I also have some string tests in here, and since they take a very long time, we'll run them, and then I'll talk about them later. So my situation is I say have this class test. Maybe it's a helper function, or maybe it's a helper class, maybe it doesn't really matter what it does. All it does is it takes in an action, right? I pass it a function pointer, and it just tracks that forever and does something with it eventually, right? So this first example, I create test referencing a method, right? Just a standard static method. Second example, I create it with a lambda function inline. And then the third example, I created it with some local function, right? These are all pretty similar. So I can actually show the memory usage of all of them. So this is in bytes. I didn't really do anything to make it look pretty. It just uses the garbage collector, collect total memory before and after snapshot to evaluate it. Pretty standard. It's an estimation, not exact. But you'll notice, with the methods, I consumed about 1 megabyte to instantiate. How many did I instantiate? 10,000? Yeah, 10,000. So they're all 10,000, by the way. So with methods, I used 1 megabyte to instantiate 10,000 of these with that same delegate, right? It's technically the same method, right? It would just be recreating the delegate. On the Lambda front, I actually saw significantly less. I only saw 240 kilobytes. So this is due to that caching thing. Technically, it eventually recreated it or whatever else, but I saw 1/4 the memory usage that I saw with delegate, like a method delegate. So then finally, I had local functions. For some reason, local functions seem to be a little bit more optimized than standard functions, but they still potentially have a larger memory leak than methods because they potentially form a closure. So, is there any questions about this? Fantastic. So our situation here was our entities have a little helper function that convert between the database type and whatever type we have, right? So if I have a database string, it converts a SQL string into a standard CLR string, right? It's a pretty common use case. Well, each of our fields was initialized with a delegate, right? And it doesn't sound like a big deal, but when we went to evaluate the memory usage of it, our memory usage of these entities were, insane. So all we did was we created a shared function, or we created a shared property, static, in other words. We created a static property that was actually reused across all of the different properties that use these delegates, and we saw a 30 to 40% memory decrease in our entities just from that one change. So that's why I wanted to bring this up. It seems minor, but it can make huge impacts if you not overuse, but if you use delegates heavily, right? So defining either a lambda or sharing one instance of the delegate is much better than recreating it over and over again. So the next thing, I've seen in our platform a lot where people are doing string concatenation and they potentially do it wrong. The problem is string concatenation with normal strings, obviously strings are immutable. So every time I combine a string, I end up recreating that string. So under manual string concatenation, every single time I add a new string, I generate a new one. So what does this really cause? Well, from what my testing has shown, we've seen that it causes basically excessive garbage collection or memory usage. Depending on the situation, it can either leak memory for an extended period of time, or it just runs the CPU like crazy to collect all the garbage, right? Because every time I generate a new string, it has to clean up the original. So what do you do about this? Well, it's pretty simple. String Builder is there in the .NET framework to help alleviate some of these issues. String builders are essentially a collection of smaller strings. Think about it as if every time I added a string, rather than recreating that string, I just track the new string in an ordered set. That's essentially how it works. It works a little different in the actual implementation, but it's just the collection of all the appended strings in order, right? This means I can append thousands, hundreds of thousands of times, and I don't waste a bunch of time collecting the garbage from manual string concatenation. So the string builder, once I complete, it combines everything when I call toString. So once I go and I need that real string representation, I just call toString, and I get the original string, well, the fully qualified string. This is much, much more efficient than string concatenation. So on my code example, I had, let's scroll down. Oh, I forgot to mention closures. So on my string concatenation, I had one situation where I had this string that's combined with all of the integers from 0 to 100,000. Well, technically 999, whatever. Got to be technical, guys. But we have one where I just sit there and append it over and over. And I have one where I just use a string builder, right? And they both result in the same string. There's no difference at all. But let me run this, because it's kind of interesting what happens between the two. Note, I output the results immediately. So right now, we're just waiting on the string builder, right? So while we're waiting on that, I'll cover the closure memory usage again. Oh, by the way, yellow bars, that means the garbage collector is running. So every one of those yellow bars, which basically have turned into a flat yellow line, is actually garbage collector running again and again and again. So if I go back to my output, it's still not done. I've only appended, I think, 10,000? Oh, there it goes. So finally, my string concatenation is done. The yellow bars dropped off, and my memory usage dropped way lower, right? Because this is when I was using a string builder. So if I look at the results, my manual string concatenation consumed, 16 more bytes than my string builder, and it also triggered garbage collection at 3 generations 4,500 times, give or take, a little bit less. So the reason why that took so long is just because of the CPU usage of it, not because of the memory, right? It just took forever in the CPU to allocate all that memory and generate all those strings, and then collect all the previous versions of it. So one thing I forgot to mention is the closures issue. I created a little example here that shows, if I wanted to get the value 40, for example, versus retrieving a value from a byte array, right? In the value with the closure, right, where I have a byte array under the hood, it's retaining that memory until the delegate has been called and dealt with. So if I go and show you the results of that, the closure, obviously since I created a 1 megabyte byte array as part of its local scope, ended up consuming 1 megabyte of memory, right? So that's just to show, that closures keep access to all that local memory defined. Any questions about that? Fantastic. So, CPU usage, that's another common issue in .NET. Obviously with the strings we had the memory usage and delegates we had memory usage. We also have, we're on a timer, guys. So with CPU usage, we actually have another issue with delegates. This is something that was not obvious, and it's technically not an issue if you're careful about it, which is why I say just understand it. When we use delegates, we actually use delegates to format rows from the database, right? Which is fine, whatever. We used our own little thing. The problem is we had n number of columns, n number of rows, and then we passed a delegate to, format each individual value of that array, right? Well, we had situations where those delegates had a loop inside them and another loop inside that. So we had potentially situations where it was n to the 5th or higher just because it was unknown that these delegates were called in an n squared loop, right? So this is just something where you should be aware. If you use loops, especially inside delegates, be aware of how that delegate is used. If it's used inside a loop, well, it's going to be O of n squared, right? If it's used inside a loop of that, then it's going to be O of n cubed, right? So another common issue that I've found is hash set versus list. This is something that's been a common mistake, is we often have a list and it's really easy to just call contains on it, right? Like if I have a list of integers and I want to find whether or not it has a value of 100, no big deal, right? Well, the problem is if you do that more than once, it ends up being exponentially slower than the hash set comparable, right? Obviously with a hash set, I look up values based on their hash code, right? Like some linear, like O of 1 comparison, right? But with a list, it has to scan the entire set. And according to the MSDN documentation, it's O of n, right? So it takes n operations to check to see whether or not list contains something. So the general rule of thumb is like, if you have to check a list once, use a list. But if you have to check multiple times, you should use something like a hash set, where you can look up that value instantly. It can save, obviously, O of n or greater operations on your CPU. So the one thing to note on hash sets is if you do implement that, especially with a custom type, it will require implementing get hash code and equals to function properly. Without those, it's going to be reference equality and it may not be correct. Thank you, Kirit. Hopefully. So on that same note, obviously, if I was searching a list for a condition, the same thing applies. Like if I have a collection of people, for example, and I wanted to find the people that started with Bob, right, as their name. That's something that if I have to do it multiple times, it's an O of n operation every single time, right? So what would be better is using something like iLOOKUP or dictionaries to find multiple values that correspond to a key, right? So the performance of iLOOKUP, which if you guys aren't familiar, the system.link provides an extension of, it's perfect. Now we don't have to worry about that. So the system.link namespace provides an extension called toLOOKUP that allows me to define a key and then find multiple values in that set from that key, right? So I can avoid enumerating the collection multiple times. I can calculate the toLOOKUP once and then use just a simple hash, right, to go find corresponding values. So I just bolded this point. Don't search lists repeatedly if you can define a key. So I created obviously another performance example for this. CPU usage. Go to the code. So CPU usage, I have a set here that is a range of 99, whatever, 0 to 100,000 again. Obviously, I have a list version of that and a hash set version of that. First check, I'm just checking to see whether or not it contains that value, right? This is an O of N search. And then I do the same thing against the hash set, right? And I measure the total processor time and how much time I saved. So the other thing I do in this code is I check to see how toLookup performs in comparison to dictionary and what it's like to search the entire list for something that I can define as a key, right? So for example here, I defined a key as the divisible by, I divided each element by 10 and defined that as a key, right? So 0 through 10 ended up under the same key, 10 through 20, right? So I have 10 in each set, right? So my examples down here just show how fast it is to find that corresponding element with a dictionary and lookup versus just searching the list again, right? So the list contains in the hash set, we can see that list contains took, 50 times as long. So, well, more like 30, but that's just for one check. So if I wanted to do that multiple times, obviously it gets exponentially worse. So two dictionary and lookup are the same story. Technically these should be more or less the same, but I had variations between each run. So the more I run it, the more like dictionaries and lookup trade blows on their performance. But that's just a variance of the processor, et cetera. So you can see also that if I search the list for a key definable condition, it takes significantly longer than a lookup or a dictionary. So our scenario was again tied to that delegates. When we went to refactor those delegates, we had to define some way of retrieving essentially each of those delegates that were passed in to format a column and row also depended on other data. Right? So how do we get that data efficiently, right? By using a toLookup, we were able to keep that n squared time to format all the different values and still accomplish the same functionality, right? Converting our n to the fourth or greater complexity loop into an n squared, right? Which is as ideal as I think we can get in our particular scenario. So obviously I had the results showing that it pulled up the same value and all it was divided by 10. So lookup had nearly the same performance as a dictionary. Any questions about that? All right, so last thing, reflection tips and tricks. There's a little image from my favorite game, Destiny. I mentioned it briefly, but it's a reflection of him, he's pointing at himself. All right, but, so at any rate, the main point I wanted to cover with reflection is I often see people checking types very incorrectly. One of the most common things I've seen is people call get interfaces and checks to see if that list contains another interface. But that's not the right way to do it. The right way to do it is you got 3 different operators for checking types in terms of reflection or compile time. Is assignable from, is instance of type, or is operator, right? These are the 3 best ways to check types. The differences between them is assignable from checks 2 types metadata to see if they're interchangeable, right? So if I have a class that inherits from another class and I have both their metadata, then I can check to see which one can be assigned to the other class, right? Simple. Is instance of type lets me check to see if an object instance is an instance of the type's metadata that I have, right? So same thing. And then the is operator allows me to do it at compile time. So if I have an object and I know the type I'm looking for at compile time, the is operator allows me to check for that and cast it even at the same time nowadays. So other ways I've seen people do it is type.equals, but I'd highly recommend against this. Unless you're checking for a specific type and you don't care about its hierarchy at all, then type.equals doesn't fit. Type.equals restricts to the exact type. So if I have class A and class B inherits from class A, type.equals from class A will only work for the type class A, right? So, and then type.getInterfaces, I have a code example showing how slow that is in comparison. The other reflection tips, and this is another thing MSDN documents, but you should cache everything that's commonly used. If you constantly end up, calling type.getMember and passing a specific method, you should cache the results of that. Doing that multiple times, it could potentially become uncached. By default, .NET will cache a lot of reflection type operations. But obviously, if you never use it, it leaves the runtime cache. So you should cache anything that you know you're going to call constantly with the reflection. So things like type information are something important to cache, where if I know I'm going to get some type information from this specific type, then I should save that type off into a variable and keep it around, right? So the other thing is like member info. If I know I'm going to target a specific property or whatever else, I can cache that member info and just reuse it over and over again, rather than having to use reflection to go get it again, right? That little bit of memory is probably worth the CPU usage you save later on. So another point is, obviously, we all as .NET developers like OOP, but we have to be aware that reflection breaks OOP rules. From the context of reflection, I'm allowed to instantiate private classes. I'm allowed to set private members. I'm allowed to invoke protected methods. Like, the sky's the limit with reflection. It's not a great thing, but you should be aware if you're going to use reflection, you ruin all of the OOP rules of those types that you're involved with reflection in. So it can change, obviously, runtime behavior too, because if you're setting fields you're not supposed to, it can change the way that type behaves. So the other trick that we've had is we've wanted to define a lot of attributes specifically on enums. When we go to use enums, there's a lot of other data we need, and so we've created a lot of custom attributes. The way to retrieve those is there's this get custom attribute extension in the system.reflection namespace. There's also attribute.get custom attribute, so you can use that to retrieve any attributes that you've applied to any members, right? So you can do it on enums, you can do it on properties, etc. Wherever you have a custom attribute, you can use that to get it. So I have some quick examples of how this performs. So I wanted to show that, like, if you go request for type information, requesting it again should theoretically be cached. But .NET is smarter than me. It seems to cache it even before I start. So retrieving the types immediately performed actually quicker than the second retrieval of it. So that's what I saw pretty consistently across the board. And obviously, the more I run this, the quicker access it has to it. So you can see that the first time I ran it, the types took a little bit to compute, even though I was computing the same values, computing the same types multiple times. The first runtime didn't have it. The second runtime, for some reason, was significantly faster. So this obviously proves that, like, if you cache it, you save all those CPU cycles, potentially memory as well. The other check was get interfaces. Retrieving the list of interfaces from an instance member or type obviously takes some time. This is all in ticks, by the way, so it's just to show the difference more than actually the time. We can see that getting it the first time took 4,800, but getting it the second time took 422, right? So I could have avoided that if I just stored off the get interfaces. But either way, get interfaces in this situation was used to see if I implemented an interface on a specific type. Rather than doing that, I can use is assignable from instead. And we can see that on the first run of is assignable from, it's 3 times faster. It takes 33% as long as the get interfaces contains. And it's pretty much the same story with is instance of type and is operator. Obviously, those have different scenarios than the get interfaces .contains check. We can see that they are all very comparable to each other and all very fast. So that's why those 3 operators are, I believe, even by MSDN, the recommended way of checking type. So, just any questions about that? That is all I got. So I put all this information up on GitHub. If you care to check out the code or check out the slides again, it's all available on my GitHub. So that's all I got. Is there any questions? Perfect.
My name is Rich Kolaski, and I will briefly discuss a migration we are going through here at Buildertrend. We're actually doing a little bit of a facelift, some plastic surgery. We are migrating from the ASP.NET Web Forms platform over to React. So it's very exciting for us as developers, but it's actually very exciting for the business as a whole. I'll get a little bit into how we got here, why we need this migration, how we're doing it, and how this sets us up for the future. This will just be a little taste. I'll actually be speaking about this at Nebraska.code. Sam Kirkland over here will be speaking about it at HTC, so we're shouting the message from the mountaintops here. This is just a taste, like a drug dealer, if you will. Jake already stole my joke, so we'll go ahead and skip through this. My colleague Adam Nodal, amazing developer, also Reddit celebrity. I added that in there. Me, Rich Kolaski, I am the applications development architect here. This image, someone found on Facebook before I had my permissions set up correctly. It's propagated to every environment that we have. I see it on developer screens, I see it in test, I see it everywhere. So why not just own it, right? Okay, so migrations. We as developers love them because it makes our job interesting. Like we get to use the new shiny thing. Oh, we get to go, this is going to make our life so much better. It's amazing. Businesses, on the other hand, need a justification for a migration, right? And yeah, spoiler alert, we have a justification. I'm going to explain it. That's why we're doing this. But I want to talk about how we got in this situation and how we're moving forward. How this will make us more money. That's what the business cares about, right? If you're not a nature buff, this is the inside of a tree. So a tree gains rings as it gains age. And this, I've actually cut open the Buildertrend tree for you, our software architecture tree. The business was started in 2006, and it's written on the Web Forms platform, which was big at the time. And it carried us a long ways, right? We're still using it today. But if you look in 2013, the landscape had changed a little bit. There was a large propagation of JavaScript frameworks. You know, there were conversations about Backbone, Knockout, Angular 1.0. I'm sure we can name quite a few others, right? But things are different than they were in 2006. And there were mobile apps as well. So in 2013, we dipped our toes in the water, started using Knockout, started using Web API, becoming a little bit more service-driven, and in tandem started developing our mobile applications. And then you carry that forward to 2018, and the landscape's different again. The JavaScript frameworks have consolidated a little bit. Things are a little bit more mature. And that's kind of where we were able to make the decision that this was the time that we would move away from web forms to something that's a little bit more supported, right? So like I said, today within our solution, as we've aged, we've gained a lot of cruft. There's been a lot of developers in and out of our solution. There's many different ways of doing things on the front end itself. We've got web-only services, we've got mobile-only services, we've got some that are shared. It's a large variety, right? And we've got Knockout and web forms on the web front end, for the most part. Obviously, jQuery thrown in there, some other stuff. But what you end up with is a diagram that looks like this, right? So we've got our web application, we've got our native apps, we've got some code behind logic, we've got some logic in the APIs, we've got some logic in our logic layer. You've got some Knockout calling into the APIs. Code behind can call directly into the logic. And then the native apps have their own APIs, and then some of them are shared. A lot of arrows here, right? And this is basically what you looked like when you saw that diagram. So, to give you a little color on how we got to that diagram, I want to talk about purchase orders. Purchase orders are a feature in our application. Our application is a construction project management system. So obviously purchase orders are a key piece of that. But the life cycle of purchase orders at Buildertrend, in 2012, we developed this in web forms. I snipped out of our source control the earliest check-in I could find. Jake, I think this is when we started using source control at Buildertrend. Yeah, shortly, yeah, somewhere in that time frame. So, but you have to understand, prior to this, it was basically Jeff, the co-founder, and then Jake was the first developer to join Jeff. So 2012, we're looking at adding purchase orders into our software. Fast forward to 2014, we're looking at adding native apps to our platform, right? So we've spent 2 years developing a purchase orders feature with a list view, a detail view, all of that functionality. And given our architecture at the time, most of that was baked into the web forms code behind, right? So as a business that wants to move fast and knows that having a native app is critical to business survival, it was not acceptable at the time to say, hey, let's slow down and pull all of this logic out of the code behind into a shared library that we can then reuse by our mobile apps. No. We're going to move fast and develop mobile services that are side by side with our ASP.NET Web Forms code. And that's what we did. And it's worked out quite well for us. But you can see the diagram starting to come together here. In late 2014 or early 2015, we had our first mobile release with purchase orders as a feature. That screenshot's from our app today. I couldn't find one from 2014. One other side note, I did pull this out of our ticketing system. Apparently I developed the first mobile purchase order services, so I don't even remember that, but apparently I was complicit in all of this. So, yeah, so it allowed us to get our mobile apps out there fast into our customers' hands. But what we're left with is a lot of baggage, right? This is what our devs are dealing with every day. You know, we're carrying web forms on our back, we're dragging Knockout along the ground, and there's a park bench behind us, right? Like that's the goal, is to just sit on the bench. We've got React there, so what are we doing? I just love these infomercial pieces where they tell you how bad things are currently. So this is, yeah, everyone's had a car wash where they've done this, right? So anyway, we are 2018, we're at a stage where we're at the scale where we're saying every enhancement we make to purchase orders, we have to write twice. We have to do it in web forms and we have to do it in our mobile app APIs, right? And on the mobile clients as well. Does that scale? Not very well. So if we want to, do we want to continue with this current tech stack, or do we want to rethink where we're at for future business agility, right? So we kind of had this decision point laid out. We had the current landscape of JavaScript frameworks, Angular, Vue, and React being the biggest names. We have Knockout, which is what our team's familiar with. It's solid. We don't have a reason to stop using it. But the ecosystem is basically dead. And then we have our current stack, which is web forms, which is in sort of the same boat as Knockout. Like, people are not adopting it today. Obviously, there's still a lot of people using it. Same with Knockout. I love Knockout. There's nothing wrong with it. But if you're looking to the future, it's probably not what you're picking for an enterprise level application. And I mean, so we go from one fork to essentially many different forks, right? We're looking for better support, better performance, better period, which is in our branding Buildertrend. So we ended up deciding on Knockout. Like, let's take this road we can get to be completely service driven and go from there. And then we kind of circled back and said, like, is this really, this migration is going to take years. We have hundreds of pages to convert. Do we want to look back at ourselves in 2021 and say, well, now we're in Knockout, nobody's, you know, done anything in Knockout as far as like libraries or tools for 10 years. Is that where we want to be? Let's reset on this discussion, right? So we came back to it, had some input from our dev team, our architecture team, We're basically saying it's a bad idea to move from one unsupported platform to another. So let's just go ahead and X out our current stack. We talked to a few other people in the industry. We had our architecture team kind of put together a proof of concept with React. Essentially where we ended up was, let's cross Vue out as too new. The ecosystem's not quite there. So it was basically Angular versus React. Some of our team had experience with Angular, some had experience with React. We came to the conclusion you could be successful in either, right? React is a little bit closer in coding paradigms to Knockout, so we thought maybe that's a little bit of economies of scale. Our team will be able to pick it up quicker. We really liked the React and TypeScript combination. I remember when our team was looking at the prototype in our meeting, people were just going nuts over coming from a C# background, the TypeScript compiler is just a huge bonus to have in sort of the front end world. React has a huge community, and we actually had identified a great sort of starting point with a component library that we wanted to use that would give us a baseline for all future development on our front end. And I'll talk about that in a little bit. So like I said, we put together a proof of concept, and then from there, we presented to our development leadership and kind of got the go-ahead with these justifications. Essentially, the headline is that we're going to build features faster, right? We're going to consolidate our different platforms we have on the front end into one, start using shared services, write our services once, use them across all of our clients, moving to a well-supported framework so we can build on the backs of other people's work. Hundreds of people are checking in hours of work to React libraries and the core framework every day. So that's going to be a huge boost for us. And that's just going to allow us to move faster. So then the next obvious discussion is, wow, we're going to rewrite our front end. What else can we do? This is Buildertrend 2.0. It's amazing. We're going to redo everything. Is this an opportunity to? This became my trigger words. People would say this constantly. Rethink our workflows. Can we do this? Can we reimagine our user experience? Can we rewrite our APIs? Oh, this makes sense. Improve our test coverage. Fully document our system. Move to .NET Core. We should containerize. We should switch to microservices as part of this. That's just a recipe for disaster. Let's get one thing going at a time, and we can talk about those things later. So in construction, there's this well-known sort of theory called value engineering, other engineering disciplines where you're kind of looking at what you have available and optimizing for function and cost. So we looked at what we had today, and we thought, what's the minimum work we can do to get off of web forms and be service-driven and set ourselves up with small tweaks today that'll have a big impact on our trajectory for the future, right? Without having to answer all of those other, is this an opportunity to questions? And as we started thinking about it, it turns out that when you start with this, you're actually sculpting. You're not painting a picture. You are taking all of this stone that you have and carving out what you actually want out of it. So we had a big block to work with. And if you start thinking about sculpting, well, let's delete the code behind logic. We'll rewrite it in React. Now we're connecting to shared APIs that we've already written for either mobile only or they're shared already. We're going to reuse them, right? Let's get rid of the web only APIs. We don't need them, right? Now everybody's connected to a share API. We're deleting rather than adding, right? So where we ended up was essentially we're replacing web forms with React, and we're reusing a lot of what we already had. We're talking about in 2012, 2014, moving fast, writing mobile-only APIs. Well, now those things are there for us to take advantage of on the web side. Let's use them. Zooming in on our React tech stack, as far as what we're doing today, we are using TypeScript. I know there's a little bit of controversy in the industry about whether you should or shouldn't use TypeScript. We love it, especially if you're coming from a C# background. We're using a component library called Ant Design. You can check it out at ant.design. Very simple. Style guide. So we have a living style guide where we put all of our web components. Developers start in Storybook. They can develop out of Storybook. You can mock data out of Storybook. It makes things very easy to work in isolation. We have standards. Kudos to our architecture team, Sam, Derek, Andy, everybody, for developing standards and being very tough on the code reviews. We're using Jest, and we're switching to the React testing library for automated testing, and we've, from the ground up, developed a way to sort of isolate where we call our APIs so you can mock those out for testing. So the future Buildertrend front-end web developer is efficient. He's sitting on a bench, and when he needs to, it extends out into a full patio set. It's amazing. Our front-end future is beautiful. So beautiful. So our current status, right now, we are kind of, when you think about our front end as a tree, we are sort of nibbling around the edge, the leaf nodes. We're doing print views, settings pages. A lot of these didn't have equivalent mobile services, so these are ones that we did have to extract code out of the code behind and expose the API. But those are actually the safest place for us to start to kind of use as a proving ground to develop our core components, our standards, our tests. And these are places where we've actually been able to utilize our internship program. How many of you here are interns? Yeah. Are you guys, you have been. You guys are working on the React conversion? Yeah. So we have 15 interns working on this, and it's pretty amazing. We didn't give them any of our code. We said, here's what it looks like today. Here's the API. Go reverse engineer our software. And they've done a great job. They've rewritten all of our settings pages, like our administrative pages for our customers. And that process is going pretty smoothly. As far as our full-time team, we're continuing on our proof of concept for our first sort of edit page, which is our warranty feature. And we're getting pretty close to punching out all the items remaining on that and rolling that out to our customers. And then in tandem with that, we've developed kind of a full retraining plan for our team. And that's been a major effort between the architecture team, Sam Kirkland and Derek Battenhorst, and our full-time dev education trainer, Aaron Deming. So those guys spent a ton of time working on a curriculum that'll retrain our entire team of devs. Like, we're going to invest that time because this is the future of our platform. These are side-by-side screenshots of before and after the migration, and I dare you to tell me which one is which. And that's by design. Like, we want to go as like for like as possible, so we get as few questions as possible when we migrate. And honestly, I couldn't even tell you which is which. So our customers won't know. And that's the great thing, is like, we've switched tech stacks, and our customers won't know. And then all those other questions, we can answer those after we're done with this, right? As far as current progress, kudos to Dan Drews for putting this together. We're tracking on how much VB code we're deleting out of our web form solution. We're at about 1.2% right now. As far as ASPX pages, 1.4%, and about 2% of shared ASCX controls have been deleted since we've started this migration. And these are things that are completely done. The replacement is live. We're removing the old code, right? So this trails a little bit of our actual publish and migration, but it's a very promising indicator. Still early stages, but I expect this to continue trending upward as we pick up steam. So what's next? Well, let's talk about Buildertrend 2.0, right? Why not? Yeah, I mean, it's an opportunity. Remember the recipe for disaster? Well, the recipe for success is executing on this migration and then talking about how to prioritize those next things. Revamping user experiences. That's going to be so much easier after we've removed this huge graph of lines, right? Now that we've deleted all of this other stuff, let's start talking about those other things because it's so much easier to do. Not saying it's easy, but it's easier. So, like I said, this is a little taste. If you want to come back for more, I will be speaking in Nebraska code. We'll be diving deeper into actual React code, diving deeper into tools like Ant Design and Storybook, diving deeper into the actual migration process. So those are the things that I'm talking about. Sam will be speaking at HTC. I'd imagine it will be similar, but I don't know what he has in his mind. We haven't really collaborated on it yet. With that, are there any questions about the migration? All right, thank you.